All right. Moving on to item number 21. Which of the following is true of 83,571 raised to 34,791? A, it is 1, it is even. 2, it is odd. 3, it is prime. 4, it has odd number of factors. Is it 1 only, 2 only, 1 and 4, or 2 and 4? Let's analyze the conditions. Now, is it even? No. How come it's not even? The base is an odd number. And if you raise the base, an odd number, to any non-zero exponent, it will be an odd number. That's why 1 is wrong. Is it odd? Yes. As what I mentioned. Is it prime? No. In fact, it has many factors. One of the factors is 83,571. You could have 83,571 squared, and so on. So therefore, it is not prime. It has odd number of factors. This is also false. A certain natural number has odd number of positive factors if it is a perfect square. But since this number is not a perfect square, how come? I knew 83,571 is not a perfect square. And since it's also raised to a number that is not even, therefore, it's not a perfect square as well. However, if the exponent is even, like it's an even natural number, I'm sure it will be a perfect square. That's why we could say that only 2 is correct. Letter B. Next number. What is the sum of all the positive factors of 144? Is it 403, 404, 405, or 407? What they usually do is that they really get the exact factors and add them. But that may not be necessary because there is in fact a way to determine the total or the sum of all of them. That is by prime factorization. In this case, we could utilize prime factorization, and that 144 is equal to 2 to the 4th times 3 squared. And all we have to do is add, to get the sum of all factors, we need to add all the powers of 2 starting from 2 raised to 0, 2 raised to 1, all the way until 2 raised to 4. That's why this is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. And also for the 3 squared, you have to add all the, what they call this, from the 0 exponent, 3 raised to 0, plus 3 raised to 1, plus 3 raised to 2, until the number itself. So all you have to do next is simplify each of them. The first one simplifies to 31. The second one simplifies to 1 plus 3 plus 9, which is 13. And therefore, you have 31 times 13, which is 403. You can verify that with manual addition if you wish. Letter A is the correct answer here. 23. How many such n element of natural numbers exists such that n all over 30 is a non-zero proper fraction in simplest form? Are there 4 of them, 5, 8, or 9? So this means that n and 30 should be relatively prime. And when I say relatively prime, their GCF should be 1, so that it would be in simplest form. And in number theory, to get the number of, if you are given a whole number, and if you would like to determine the number of positive natural numbers less than or equal to it that are relatively prime to it, no? I mean less than the given number and are relatively prime to the number, all you have to do is you could do prime factorization. 30 could be expressed as 2, 3, and 5. So from here, what you do next is you will multiply the number 30 and subtract it from 1 minus 1 over the prime factor. So in this case, we have 2. 1 minus 1 over the next prime, which is 3. And times 1 minus 1 over the last prime, which is 5. If you have 5 prime numbers here, then 1 over the next prime times 1 over minus 1, 1 minus 1 over the next prime. And take note, what about, sir, if there are exponents? Let's say this is 2 cubed, 3 squared, 5 to the 4th. Don't worry, just take the primes and disregard those powers. No? Disregard, because this technique works regardless of the exponent of your prime number. 1 minus 1/2 simplifies to 1/2. 1 minus 1/3 simplifies to 2/3, and 1 minus 1/5 simplifies to 4/5. And getting their product with 30, no, multiplying these 4, 30, 1/2, 2/3, and 4/5, you get 8. And if you are not convinced, those 8 are the ones I listed: 1 over 30, 7 over 30, 11 over 30, 13 over 30, 17 over 30, 19 over 30, 23 over 30, and 29 over 30. Hence, the correct answer here is letter C. I hope you got letter C correctly. 24. What is the remainder when 3 raised to 100 is divided by 8? 0, 1, 2, or 3? I doubt if your scientific calculator can handle that. But there's actually a technique here. And that technique is, in my case, what I did here was, I could notice powers of 3. No? If I divide 3 by 8, the remainder is 3. If I get 3 squared, 9. But wait, 9, when divided by 8, gives a remainder of 1. That is the reason how come I have 3 squared. And I express 3 raised to 100 as 3 squared raised to 50. Because I know that when 3 squared or 9 is divided by 8, the remainder is 1. That's why 3 squared is 9, no? So we have 9 over 50. And as what I mentioned, when 9 is divided by 8, which is your divisor, then the remainder is 1. And if you will raise 1 to 50, that will be equal to 1. Because 1 raised to any exponent is any real exponent is still 1. Hence, 1 is the remainder, and that letter B is the correct answer here. 25. Which of the following is true? If a number is divisible by 3, then it must be divisible by 9. If a number is divisible by 121, it must be divisible by 11. A 9-digit number is divisible by 8 if the last 2 digits is divisible by 8. Or a perfect square number could end with 2. And actually, what is correct here is A correct? If it's divisible by 3, it must be divisible by 9. This is false. How come? Example, 6. 6 is divisible by 3, but not divisible by 9. And B is actually correct. If a number is divisible by 121, it must be divisible by 11. How come? Because 11, is a factor of your divisor. And if it's divisible by your divisor, then it must also be divisible by the factor of your divisor. That's a concept in number theory. A 9-digit number is divisible by 8. If the last 2 digits is divisible by 8, it's wrong. A number is divisible by 8 if the last 3 digits is divisible by 8. And lastly, a perfect square number could end with 2. Whatever number ending of that number, if it ends with 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, if you square that, you could actually see na hindi siya, that it's not divisible by 2. That I mean, it would not end with 2. Hence, letter B is the correct answer here. Okay. Next, 26. What do you think is the answer here? Find the value of the determinant of the matrix of this 2 by 2 matrix with elements 8, 4, negative 1, 3. Is it 28, 20, 15, or negative 28? Now, so if you have a 2 by 2 matrix, there is a shortcut in finding the determinant. That is, you will multiply first all the numbers in the main diagonal, 8 times 3, and subtract it with the entries with this one, no? Negative 1 times 4. 8 times 3 is 24, negative 4 times negative 1, it's plus 4. That's why we have 24 plus 4, which is 28. And this is the value of our determinant, letter A. 27. I hope you are still doing fine out there. Feel free to pause the video and go back from time to time if you need to. Find A plus B if A is the matrix with negative 1, 3, 4, 8, and B is 8, 1, 5, 3. And how do we get the sum of two matrices? First, it's very important that the two matrices being added are identical in terms of the number of rows and columns. So here they are both 2 by 2, so we could add them. So from here, A plus B is simply adding their respective elements. So negative 1 will be added by 8, 3 will be added by 1, 4 will be added by 5, and 8 will be added to 3. So in such, we have A plus B, which is 7, 4, 9, 11. Letter A. I hope you got A correctly. Next number, 28. The product of 3 by 8 and 8 by 4 matrices is a blank matrix. Is it 3 by 8, 8 by 3, 3 by 4, or 24 by 24? Note that you can only get the product of two matrices, or you could multiply them, if the number of, take note, the first number here is the row, this is the column. 8 here is the number of rows of the rows, and its number of columns is 4. We can only multiply them or get their product if the number of columns of the first matrix is equal to the number of rows of the second matrix. So in this case, they are equal to 8, so we could get the product. And the product of an M by N and an N by R matrices is in fact M by R. And using the above pattern, we could say that their product must be the product of a 3 by 8 and an 8 by 4 matrices is a 3 by 4 matrix. And that is letter C. 29. A square matrix is non-singular or invertible if it has an inverse. The following matrices are non-singular except, okay, there is also another way to tell if it is non-singular or if it has an inverse. Remember that a certain matrix has an inverse if the value of its determinant is not equal to 0. And from here, you may check with the other options, but here let us take option C with elements 4, 3, and 8, 6. So you could see here the 4, 3. If you multiply them, if you get the determinant, 4 times 6 will be 24. 8 times 3 will be 24 as well. And 24 minus 24 is 0. Hence, the determinant of C is 0. And since the determinant is 0, meaning to say it has no inverse. Therefore, this is non-singular. Sorry. Uh, in this case, since the remainder or the determinant is 0, therefore C has no inverse. Letter C is the correct answer. You may check with the other options, but I'm sure that their determinants are not 0. Also, another way of spotting if the determinant is 0 is you could see that if you have the first row, if you multiply it by 2, it will become 8, 6. So if you could multiply any row by a constant and that will be equal to another row, I'm sure the determinant will be 0. Also, if you could perform row operations and resulting to a 0 column or 0 row, then that's another indication that it has no inverse. 30. The trace of a matrix A denoted by trace of A refers to the sum of the elements in the main diagonal. Find trace of A if you have this matrix here. Is it 34, 28, 25, or 3? And when we speak about main diagonal, it is here from the upper left to the bottom right. So the elements of the main diagonal are negative, or the numbers in the main diagonal are negative 19, 14, and 8, and their sum is 3. And thus, the correct answer here is letter D. I hope you got D correctly.